Hello Year 8, Mr. Angier here. I hope you're safe and well, and welcome to week 2 of climate change. Our inquiry question for this week is, what are the causes of climate change? Just as a reminder, your classroom teacher is the person to submit your work to at the end of this week. In order to understand our inquiry question, we need to break it down into 3 steps. So what is the greenhouse effect and what is the enhanced greenhouse effect? That's the first thing that we need to tackle. Who causes climate change and what causes climate change are then going to be accessible to us. And just as a reminder, you need to do one of these topics, and as you can see, the topics get a little bit more tricky the further across you go. Okay, so if you want a real challenge, this one here is the one to go for. If you're finding this a little bit more tricky, start with this first one over here. So the greenhouse effect. Now this is really important. First thing that I would say is the greenhouse effect is a totally natural phenomenon. It's always been happening, and actually if we didn't have the greenhouse effect, the average temperature on the Earth would be minus 15 degrees C. And that means that really it wouldn't be habitable for us. So we owe our existence to the fact that this greenhouse effect works, and the way it works is as follows. Now sunlight is what's known as UV radiation. Okay, so UV radiation, and it's what we call short wave. It's really short wave. Its wavelength is very short, as I'm trying to do the mouse here, not particularly well, that's a short wave radiation, and being shortwave, it finds its way through the Earth's atmosphere nice and easily. Right? So it's very easy for shortwave radiation to get into our atmosphere. Now what it does is it warms the surface of the Earth. So we've got some lovely warm surface of the Earth here, a little bit like a radiator almost, although it's heated in a different way, heated by the sun. A little bit like if you go out and you have a patio or anything like that, you put your hand above it, sometimes you might feel there's actually quite a lot of warmth coming off the Earth, or just a road surface. That's being warmed by this UV radiation. Now once the Earth is warm, it starts to emit this long wave radiation. Alright, so this long wave radiation here, and this is infrared radiation. Infrared radiation, being long wave, has a much harder time getting back through the atmosphere. Now some of it escapes into space, but a lot of it is bounced back down towards the Earth, and it's kept, and it keeps us nice and warm. So that's essentially how the greenhouse effect works. Now what we are doing in the enhanced greenhouse effect, if I just put an E in front of greenhouse effect, and the enhanced greenhouse effect is when humans are thickening the atmosphere with this layer of CO2 and other greenhouse gases, and that means that there is less heat escaping. Alright, so I'm just going to get rid of this heat that was escaping into space, and I'm going to replace it with a double line. Right, so that heat that was escaping into space is now getting more readily bounced back towards the Earth, and as a result our Earth is beginning to heat up. Okay, so hopefully that gives you a brief understanding of the greenhouse effect, and that's the first thing that you really need to understand before you can go on and recognise some of the other issues associated with our inquiry question this week. Okay, so knowing then that human causes of greenhouse, or certainly that humans potentially might be changing the climate, we need to understand who, what, why is happening, and this is always a good slide because here we have a map of the biggest emitters of greenhouse gas. So you've got the USA over here, they're very naughty. We've got China, oh dear China. We've got the EU, I'm afraid that we're quite big emitters of greenhouse gases as well. We've got India. But actually, if you look down at the bottom, this is just the total number of emissions, okay? And you always have to be a little bit careful before we start blaming the Americans or the Chinese or the Indians or ourselves, because of course, there are some countries with much larger populations than others. Now, if we have a look at some of these, the USA has a total population of 328, and these are all in millions. Okay, so 328 million. In Europe, we have 741 million people, and of that, the EU countries is 446. So we've got 446 million in Europe. China is 1.3 billion. So forget what I said about millions a second ago. This is now in billions. I'll put a B there. India is 1.2 billion. So all of a sudden, although we could perhaps say that China is the biggest emitter, it's perhaps a little bit unfair to say that, because there's so many more people living in China than there are in Europe. And actually, if we doubled the number of people in the EU, we'd probably have a bigger circle. And the same goes for the United States with 328 million people. Well, they're not that much smaller than China, that has roughly an additional 1 billion people. So we have to be clear about this. And I also want to highlight a couple of other naughty countries down here. We've got Australia. Now, they've got quite a large emission rate there, but they only have a population of 25 million people. So that's significantly less, obviously, than somewhere like India, which has its 1.2 billion people. Same goes for Canada. Slightly higher population there, but still only 37 million people living in Canada. So it's something that you need to be aware of before we start slinging mud at those countries that appear to be producing quite a lot of emissions. What this map does show, however, is that there are some countries producing more emissions than others. So plainly, there is something or something of a rabbit hole for us to go down here and to explore further. Now, if you choose, I think it's the third most difficult topic. If you choose to, you are going to be investigating some of the human causes of greenhouse gas emissions. And I'm not going to tell you what they are, but I am just going to introduce you to some of the possibilities that you might explore. So this one over here, I'm not sorry, well, I'm going to tell you what they are, but I'm not going to explain them to you fully, because that's what you're going to discover. Now, this one over here is deforestation. So we are cutting down a lot of the trees here. So I'd like you to think about the impact that might have on the concentration of CO2 levels in the atmosphere. Remember last week we saw, didn't we, how big a part trees can play in reducing CO2 levels. We've got these characters over here, cows. Again, have a think about what this this beef farming is contributing to. What might be what might be the cows? What might they be doing in order to increase, I suppose in their case, levels of methane? It's all pretty unpleasant. Number 3 over here, we've got a car. Think about what comes out the back of cars. Again, maybe do some research as to the specific gases coming out of the back of a car. So this one looks like a diesel car to me. And number 4, now these are, this is a power station. This is something to consider as well, because a lot of our power, a lot of our electricity actually comes from the burning of coal, oil or gas. And these are these are big emitters of greenhouse gases. Lump of coal, oil or gas is actually a store of carbon and many other greenhouse gases. So when you burn it, all of those nasty gases get released into the atmosphere very quickly. So again, something for you to investigate there. Now, it's absolutely true to say that the climate has always occurred naturally. And again, like I said last week, I'm sure you've heard of the Ice Age, and you might have seen the movie, but we have got periods where the Earth has always been colder and always been warmer. So these cold periods are called glacial, and that means essentially a bit of an ice age. We've got lots of ice on the land, and these warmer periods are interglacial, and interglacial periods are actually characterized by there being no ice on the land at all. So you can see here we're not actually in an interglacial period, because we do have ice in Antarctica, and we have ice sheets on some of the land, so we're not actually at our warmest stage yet, and that's important to realise and to know. However, I think as I showed you last week with some of the graphs and charts, there's some significant concern about how quickly we are changing our climate. Again, if you look at the x-axis down here at the bottom, this scale is very, very long. So these changing periods do take a reasonable amount of time. They don't change in 100 years. So the climate changes naturally, and how it does this is, again, something for you to investigate. Now, you've got three ways here. You've got Milankovitch cycles, you've got sunspots, and volcanic activity. Now, these are all ways in which the climate can and has changed naturally. On the PowerPoint version of this slide, you've got some sources of information here, here, and here. And on this side, I have talked about whether it's an increase, decrease, or both in terms of temperature. Okay. So, in summary, what we have talked about is how the greenhouse effect works, what causes climate change. I've suggested some things there for you to go away and research, and who causes the climate change. Again, some suggestions as to what kind of human activities you can go for. Thank you very much. I hope you enjoy investigating this week's question, and any problems, please let your class teacher know. Thanks very much.